Hi, my name is Edona Kurtolli, and I'm going to talk about machine learning, managing machine learning projects, which is part of Duke University offered through Coursera. So I'm going to break down the opportunity for applying machine learning to a problem of my selection. Well, let's change the slide. All right, so what I'm going to include here are uh, basically my agenda and what I'm going to talk about. I will dive into evaluating by opportunity to clearly define what the problem is. Then I'm going to talk about crisp DM business understanding, followed by a solution validation plan, the machine learning system design, and I'm going to also look at any potential risks in production. To start with the opportunity evaluation, let me first say that the opportunity that I'm looking at is the problem of tracking and managing material flow in supply chain, focusing on disruptions and various transportation routes. So, in defining the problem, this involves managing and optimizing the flow of material between various stages of the supply chain. So, in suppliers, manufacturers, distributors, and their different transportation nodes, such as highways and freeways, and any types of ports. So, any disruptions, such as strikes, weather events, unforeseen issues can cause delays and become problematic. The three boxes that I have below are the three important questions that I'm trying to answer. So, is there a problem? Can machine learning help? And who cares about it? So, obviously there is a problem, so that's why I've selected this. And the problem is that having these disruptions will have a substantial impact on operational efficiency and financial performance of specifically tech companies. Any delays on material flow can result in missed deadlines, which increase costs and make for a loss of competitive advantage. How can machine learning help? It can help by engaging in predictive analytics, in some sort of real time monitoring, optimization, and anomaly detection. So we can analyze historical data, we can use real data to process real time stuff, and also use the machine learning algorithm to optimize any type of routing and scheduling decisions, so to say. Who cares about this problem? Since I'm focusing on tech companies, obviously tech companies, their supply chain managers, category managers, logistics providers, and then finally the final user here would be the customer because they want lower costs, obviously. As a summary, the opportunity to apply machine learning in tracking and managing material flow is attractive because of the potential significant improvements in the operational efficiency. And by leveraging machine learning, predictive analytics, real time monitoring, and optimization, tech companies can do a better job in managing their risk. Now, I'm going to look at CRISP DM, and in the CRISP DM, we're going to focus on documenting the problem, defining what success is, so basically outcomes and outputs, and then identifying relevant factors here. So let me move to CRISP DM. I think that one is next here. I have several slides on it, but I'm not going to stop in all of them because I know I only have 5 minutes. Summarizing what I'm trying to say throughout these here is that in business understanding, which you'll see the labels up here, in business understanding, documenting my problem has been crucial. So I'm looking to manage and optimize material flow. How am I going to define success? I'm looking at the reduction of disruptions, which improve delivery performance, cost saving, and predictive accuracy. And then how am I going to define relevant factors? By looking internally and externally at different stakeholders. So, any data that shows past disruptions, any data that shows weather and traffic disruptions, and any information that comes from software ERPs, as well as any regulatory and economic factors, so to say. Um, when looking at data, and this is critical, it's important to ensure that you're looking at the right sets, so to say. After you've selected any type of traffic APIs through Google, let's say for example, you will have to validate that data and explore the data for further in order to ensure that you have all the you're applying the simplification of any um, data methods to uncover the relationship pattern, so to say. But to summarize more or less the data understanding, in this case over here, gathering data, validating and exploring it, it will pave the way for the effective modeling and ultimately will help achieve the objective that I'm trying to get to here. Now, splitting the data and determining the feature set, I will skim through this super quickly. I'll go into model selection in a little bit, and then evaluating it most likely through MSC and making sure that I have a good test set and validation set and all that. Moving all the way through deployment and automation. I'm gonna stop at the solution validation plan for just a second here, and I have these two sections on the slide here that I want to stop at for a minute on the solution concept. So my aim is to create some intelligent routes which are going to help this model analyze features in real time and determine routes and possible disruptions for material flow. And the features that are used are the weather conditions, road conditions, supplier site locations, any parts tied to these sites, and the way where material is going from, let's say, site A to site B. And of course, events that are around these areas and modes of delivery, if it's by ship or by, I don't know, port or by highway or whatever that is. To validate my concept, historical data should be used for the mockup model. Uh, Deploying the model and collecting, excuse me, real-time data, using real-time data for the machine learning model, rolling it out and executing it in iterations. For which machine learning system to pick now, quickly summary, cloud versus edge. For me, it was best to do a hybrid approach because cloud-based systems are better for large scales of data. And as I mentioned earlier, I'm looking to tackle in a lot of it. Then offline versus online learning. Online learning here is probably most beneficial for dynamic supply chains, but perhaps some sort of a combination with periodic offline training will provide a good balance. And then in terms of batch versus online prediction would be more preferential in my case for real-time decision making. I am approaching the end here super quickly. What can be some potential risks? I've listed what I have learned through the module. We're looking at model drift, performance degradation, all the way to user adoption. But the key, especially in application here, is to retrain the model as the accuracy of the model needs to remain high. This is so far what I have for my project, and I hope that you got to enjoy this project with me. Thank you.